In this topic, we're going to focus on polygons and triangles, sides, and angles. When you get to the SOL, the first thing you should do, because there's always going to be questions about polygons, is make a list starting with 3 for the number of sides that a polygon could have. So you write down 3, 4, 5, 6, 7, 8, 9. You can do this for as long as you want to. Just to get yourself started, go at least from 3 to 12. Then you're going to list the sum of the interior angles and the sum of the exterior angles, and we'll go from there. So you always know, we always work with triangles. Triangles have a sum of their interior angles being 180 degrees. From there, keep adding 180. So get out your calculator. 180 plus 180 is 360. Just keep adding 180, add 180, and you get 540. Just keep adding 180 with your calculator. Just keep adding 180, and we continue to add 180 until we run out of our list. So we get 720 plus 180 makes 900, plus 180 makes 1080, plus 180 makes 1260, plus 180 makes 1440, plus 180 makes 1620, plus 180 makes 1800, and we could keep going. Now you could remember the special formula that's n minus 2 times 180, where n is the amount of sides or angles, or you could just make this list real fast before you take the SOL on your scratch paper. Then, if we want to know just one interior angle, we need to divide the sum by how many angles there are. So 180 divided by 3 makes 60. One angle is 60 degrees. 360 divided by 4 is 90. If it's a regular polygon, one of those angles will be this, and so on and so forth. Divided by 5 equals 108 degrees. Divide this by 6 equals 120 degrees. Divide this by 7 equals, and keep going. Divide by how many that is, and make your list. Maybe grab your calculator and you can do this on your own. Then we get to the exterior angles. Well, we don't really need a list for this because the sum of the exterior angles is always 360 degrees. No matter how many sides or angles it has, always 360 degrees. So every polygon, sum of the exterior, 360 degrees. Now, if we want to find just one of those exterior angles, one of them, that again requires dividing. We have 3 in a triangle, so divide it by 3, 120 degrees. Divide it by 4, 90 degrees. Divide it by 5, divide it by 6, divide it by 7. Keep dividing so that we get just one of those exterior angles, because sometimes the question asks for just one of those angles. You can grab yourself a calculator and you can do this too. Also, that exterior angle adds with this one, the interior angle, to make 180. So that's a way to check that we've done it correctly, and you can complete this list on your own. So you write this on your paper, and now you have a quick reference guide so you don't have to do the work every time. Now, tessellation relates to polygons because we tessellate, or we tile, with polygons. Around any point, it's important to remember, like a point where all the polygons come together, the angles must add up to 360 degrees. Because notice if we put this angle together with this angle, together with this angle, together with this angle, it goes all the way around a circle, which is 360 degrees. So keep that in mind as we do our next couple of examples. Number 1, the floor plan for a modern home is modeled by the composite of the regular nonagon and triangle shown. Nonagon sounds like 9. Triangle, well, we know that's 3. 9 sides and 3 sides, but they do show us a picture. What is the measure of angle JKL? So the first thing to do is remember to find that angle and show what it is so that we know what we're looking for. So first thing is, I see this as a very obtuse angle. So probably something close to almost a straight angle, like close to 180 degrees, is a good guess. So I might, if I'm not sure what to do, be guessing something that's close to a straight angle. So maybe C or D is a good guess. Now, To do this without having to guess, let's think about that we have a nonagon. If I go back to my list at the top of my paper, nonagon 9 sides, the interior angle is 140 degrees. So I go back to my problem and this one interior angle is 140 degrees. Triangle, I go back to my list, triangle, the interior angle is 60 degrees. So going back to my problem, this interior angle right here, 60 degrees. And what did we say? Around any point, all of those angles have to make a circle, have to add up to 360 degrees. So what's 140 plus 60, the two angles I already have, and 360 minus what I already have, and that's 160. So see, I thought that was close to 180, but I was picking some things that were too close, angles that were too close. 160 degrees is the better answer, the correct answer. Let's look at one more example for polygons. A polygon is shown. What is the measure of angle U? So here's angle U. It's interior of this polygon. Let's determine how many angles there are. 1, 2, 3, 4, 5, 6. So again, I go to my list. 6 interior angles all add up to 720. So I know that the sum, what they add up to, is 720. Sum, I think add. So I'm going to add these. These are congruent marks, which means this is also 150. These are right angles, which means these are 90, and this is the angle I want to know, which is the same as this angle. So call this angle U. This is also like angle U. So I'm going to say 150 plus 150 plus 90 plus 90. These are all the angles I know. Then the two angles that I don't know, so I could call them X if I like, but that might be confusing from this angle. It's angle U, so I have two of those because they're the same as each other. Has to add up to 720. So all that together makes 480 plus 2U. I can subtract 480. So 2U equals 240. Divide by 2. And that makes 120. So again, use some common sense. This is a very obtuse angle. So right off the bat, I could have said, I know it's not this and I know it's not this. And actually using a little bit more logic, this can't be greater than 180, so that wouldn't make sense either. Let's get to triangles specifically. First, ordering sides or angles. If you don't have a picture, drawing and labeling a triangle, making a picture, or labeling what's given is very helpful. Then find a missing angle measure if it's necessary. So going through this list for example number 3, we already have a picture, but I don't have all 3 angles, I only have 2. Well, I remember in a triangle, all 3 angles add up to 180, so let's find the missing one. 65 plus 45 makes 110, and 180 minus 110 is 70. So the one that I'm missing, right up here, 70 degrees. I drew and labeled the triangle, but it was already there, so I didn't have to. I found the missing angle measure. There it is. It was necessary. Now list the angles or the sides in the order given. Usually they ask to go from small to large, but let's read it to make sure. Which shows the distances between the boys in order from least to greatest. So I want to order what I have from little to big, from small to large. So I'm going to start with the small angle. 45 is the smallest. That's angle K. So 45 is angle K. If I start with just ordering the numbers, that could help too. So 45, then 65, then 70. K is the 45, J is the 65, and L is the 70. If I want the distances, however, the distances means the sides. So here's all I have to do. In a triangle, the smallest angle is across from the smallest side. But we don't have to have a picture for that. We just have to know that if it's across, that means I'm not going to use that letter. So if K is the letter for the angle, it's the other two letters that would be the sides. So see, that letter, and then I don't use that letter to name the side. J is the letter for the angle, so K and L, the other two letters for the side. L for the angle, so the other two letters for the side. Now I have the sides, or the distances, from small to big. Now I just have to match it. Well, JL is not that. It is this. It's not that. It is this. JLLJ, same thing. Next, KL. That's not KL. This is, so this is the correct answer. Let's look at another one. So that was the fourth step. Use the missing letters to write the other. That's what we did here. Last one for this section, number 4. 3 survey markers are located on a map at points H, I, and J. A triangle is formed by connecting these markers by strings so that HI equals 150 feet, HJ equals 245 feet, and IJ equals 365 feet. Draw and label a triangle. Let's do that first. So triangle and HIJ. Now it doesn't matter if I draw it pretty, I just have to label it the way they said to label it. It's HI is 150, so from H to I, 150. HJ 245, and IJ, 365. Find a missing angle measure if necessary. Well, I wasn't given any angle measures, so I'm not going to find any angle measures. List the angles or the sides in the order given. Well, how do they want it ordered? Which statement is true about the measures of the angles? Some are small, some are large. They don't ask for an order. So just because we usually go small to large, let's order it that order. Smallest is this side, HI. Next smallest is 245. You know what? Let's put the numbers first like I did in the other example. 150, 245, 365. Then HI, 245 is HJ, and 365 is IJ. Then we use the technique of use the missing letters to write the other. So if this is HI, the missing letters J. If this is HJ, the missing letters I. IJ, the missing letters H. This is the smallest, J. This is the largest, H. H is the smallest. Nope. H is the largest. I is the smallest. Nope. I's in the middle. H is the largest. Yep, there it is. Determining if a triangle exists. Usually you're going to be given 3 sides to do that. Add the smallest sides. That must be larger than the third side if it's going to work. For example, John wants to make a triangular garden. Which of the following are possible dimensions? We have to look to make sure they're not asking which is not possible, because sometimes they ask that. So of these 3, 6 and 8 are the smallest. So I do 6 plus 8, that equals 14. It is bigger than 10. 14 is bigger than 10. So this one is, oh, it is possible. Okay, so right off the bat, we found the one that's possible. Why are the other ones not possible? Just in case choice A wasn't the correct answer at first. 4 and 5. 4 plus 5 is 9. 9, is it bigger than 10? Nope, not bigger. So it doesn't work. 8 plus 12. 8 plus 12 is 20. 20, is it bigger than 20? Nope, not bigger than 20. And 6 and 6 add up to exactly 12. That's the third side, and that's also not bigger than the third side. And last but not least, finding the possible length of a third side given 2 sides of a triangle. Sometimes instead of being given all 3 sides, we're only given 2 sides. You need to add and subtract those two given sides. The third side must be between those two numbers. For example, two sides of a triangle are 7 and 4 centimeters. Which measure could not be the length of the third side? So we do 7 plus 4, and we do 7 minus 4. So sometimes the answer choices are like this. We might say that the possible lengths are between 3 and 11. It might be that the possible lengths are written like this: 3 less than the third side, less than 11. Can't be exactly 3 or exactly 11 because between means it can't equal it. So don't be confused by the ones that are underlined with the equals. We do not use those. Or you could choose from a list to drag and drop. So any possible lengths between 3 and 11? 3.1, 5, 6.5, 10.999. Anything between those is a possible answer. Now remember, this one said which could not. So we're looking for the answer that is not between 3 and 11. Not between those. Not between 3 and 11. Not 3.1. Not 5. Not 6.5. Not 10.999. This is between 3 and 11. This is bigger than 11. Ding, ding, ding. We've got it. 4 and 10, also between 3 and 11. Thanks for playing.